Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. This is 11.2, Rationalizing the Denominator, Day 2. Three things that must be true for a radical to be in simplest form. There can be no perfect square factors in the radical. The fraction has to be in simplest form, and there can be no radicals or square roots in the denominator. All right. So here is part of an example that of exactly what we're talking about. The example is 2 over the square root of 5. We cannot have the square root of 5 in our denominator. I talked to you about that yesterday briefly in that video. So what we're going to do is we are going to bring over our entire fraction like we did here. We want to multiply whatever our radical is in our denominator. So in this case, the square root of 5. Anything I multiply by the denominator, I'm going to also multiply by the numerator. The reason why we're multiplying by the square root of 5 is that's going to take us from here down to the square root of 25. Well, the square root of 25 is 5, and now I do not have a square root in my denominator. What that has done to us, though, is because since the rule is anything I multiply by the denominator, I must also multiply by the numerator, I do have to multiply 2 and the square root of 5, which leads me to 2 root 5. Since I cannot simplify 2 root 5, I'm just going to keep it the way it looks, and we will be done with our answer 2 root 5 over 5. Okay? So let's go ahead and look at a few more of these. We have 3 over the square root of 3. The first thing we'd want to do is make sure that the square root is not a perfect square already. If it's already a perfect square, I can just evaluate it. I do not have to multiply by the perfect square. In this case, the square root of 3 is not perfect. So what we're going to do is go ahead and multiply by the square root of 3 over the square root of 3. Well, 3 times the square root of 3 will get me 3 root 3. Root 3 times root 3 would get me root 9. At this point, what I can do is I can evaluate this root 9. So I'm going to keep the numerator as 3 root 3 over. Well, the square root of 9 becomes 3. Now, we have to check and see if I can cancel anything out. Well, because I have this 3 that's outside the square root and this 3 which is outside of a square root, I can cancel those, which will leave me just with the square root of 3 as my answer. That would be it. Okay. Now on to B. I have 6 over the square root of 9. Again, like I said just a minute ago, we want to make sure that the square root is not a perfect square, because if it is a perfect square, we're going to go ahead and evaluate that perfect square. Okay? So in this case, the square root of 9 is a perfect square. So instead of multiplying by the square root of 9 over the square root of 9, I'm just going to take the square root of 9, and that is 3. Well, 6 over 3 then can be simplified into 2, and that's my final answer. I can get to 2 by multiplying the square root of 9 over the square root of 9. It's just going to take quite a bit of extra work. Okay? On to C. I cannot do anything with the square root of 7, so at this point I do have to multiply by the square root of 7 over the square root of 7. Well, 3 times the square root of 7 gets me 3 root 7. Square root of 7 times the square root of 7 would get me the square root of 49. Now I need to go ahead and finish this problem off. There's nothing I can do with my numerator, so I'm going to keep that as 3 root 7. The square root of 49 is 7. I cannot simplify the 7 that's inside the square root here and the 7 in the denominator. Those cannot be simplified because the 7 in the numerator is inside of a square root and the 7 in the denominator is not. So that is just my final answer. Okay. On to D. Again, there's nothing I can do with the square root of 2, so at this point I have to multiply by the square root of 2 and the square root of 2. Well, 10 times the square root of 2 is 10 root 2. The square root of 2 times the square root of 2 is the square root of 4. Now I can go ahead and evaluate the square root of 4, so it's 10 root 2 over 2. Notice I do have two numbers outside of square roots that can be simplified with one another. Both 10 and 2 are divisible by 2, so I can turn the 10 into a 5. We end up with 5 root 2. Okay. On to E. Now E gets a little more tricky, but it's not absolutely impossible, okay? Everything that's inside the square root at this point, none of it is a perfect square. So I'm just going to multiply the square root of 7x over the square root of 7x. I want to multiply by everything that's in that square root down there, okay? In this case, since they're both inside of square roots, I can actually multiply the 5 and the 7. So I'll end up with the square root of 35x over the square root of 49x squared. Since 49x squared is a perfect square, I can go ahead and evaluate that. So 35x over the square root of 49 is 7. Square root of x squared is x, and I would actually be done because 35x is inside of a square root, 7x is not, so none of those pieces can be simplified with one another. On to F, the final problem that we're going to do today. I have the square root of 11 over the square root of 12x to the third. What I'm going to do again, none of those things are perfect squares, so what I'm going to do is I'm just going to go ahead and multiply by the square root of 12x to the third power over the square root of 12x to the third power. What that's going to get me, since 11, the square root of 11 times the square root of 12x to the third, since they're both inside of perfect square, or inside of square roots, I'm actually going to multiply the 11 and the 12, so I end up with the square root of 132x to the third over, it would be 144 x to the sixth underneath the square root, because 12x to the third times 12x to the third is 144x to the sixth. At this point, I can evaluate the, I can simplify the 132x to the third. 132 can be broken into a perfect square and a non-perfect square. It can be broken into 4x to the second times 33x over 144x to the sixth is all perfect squares. The square root of 144 is 12. The square root of x to the sixth is x to the third. So at this point, I'm still looking to try to simplify everything in the numerator, but I have rationalized my denominator. I've gotten the square root out of the denominator. So 2x squared, or 4x squared is actually a perfect square. So the square root of 4 is 2. The square root of x squared is x. That can be multiplied by 33, the square root of 33x, I'm sorry. All that's going to be over 12x to the third. Well, 2 and 12 can cancel, turning the 12 into a 6. I have 1x in the numerator, 3x's in the denominator, so the 1x in the numerator will go away. The cubed will turn into a squared. So I'm left with the square root of 33x over 6x squared. That is actually the end of our lesson. So what you're looking to do here is you are looking to see if the square root in the denominator is a perfect square first. If it's a perfect square, go ahead and simplify it. Go ahead and evaluate that square root. That will get rid of your square root in the denominator right away. If it's not a perfect square, what you need to do is then multiply both the numerator and the denominator by that square root. This will allow you to get rid of the square root in the denominator, and then you can simplify like we have in the past. If you have any questions over this lesson, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.